Hello, and welcome everyone to this webinar, to Open Banking and Beyond, developing APIs that are resilient to every new initiative, with Patrick Poulin from API Fortress and James Walker from Curiosity Software Ireland. This webinar will show why enterprises across banking, retail, telecoms and more are combining model-based testing and API test automation to overcome API complexity. You will see how Test Modeler builds rigorous API tests automatically in Sprint, pushing them to API Fortress for execution, an approach that enables QA teams to ensure that APIs deliver business value, building seamlessly on the skills and techniques they use today. I'd like to pass over to James and Patrick for the rest of the webinar.
Great, thank you so much, George, and welcome everyone. As George said, my name is James Walker. I'm one of the directors at Curiosity Software. Maybe just a little bit of background to the company before I hand over to Patrick. So we used to be a company called Grid Tools, and we got acquired by CA a few years ago, and we've now kind of reformed under Curiosity Software. And we're basically split into two kind of main products. The first one is Test Modeler, which is all about creating high quality test automation with notions like coverage, and being able to create maintainable automation very quickly. And the second product we have is called Test Data Automator, which is in the test data management space, which is all about being able to create high quality test data in the right place at the right time to support your testing. So they both kind of go hand in hand, and obviously we're going to be touching on both of these in the webinar today. So Patrick, do you want to say a few words?
Sure. So I'm Patrick Poulin, CEO of API Fortress. We actually started the company around 2014, and specifically API Fortress is an API quality platform. So that means all facets of quality, from functional testing to load testing, monitoring, and so forth. A little background on me is that I've been in the API space for about, I'd say 8-9 years now, and about half of that has been at API Fortress, specifically in API testing and monitoring. James?
Yeah, fabulous, thanks. So today we're going to be talking about, obviously open banking and API development and testing. And as part of that, we're going to be going through kind of the integration between API Fortress and, Curiosity's Test Modeler. And in particular, we're going to look at how the combination of these two products can help you, really extensively test your APIs very, very quickly, keeping up with, the rate of change that we face in the agile environments that we're working in today. So a bit of a kind of rough agenda. My PowerPoint decides to work. There we go. So what I thought we would do firstly is go through thinking about, understanding APIs and, the complexity that we're facing while we're testing them. We're then going to take a look at a new approach to testing APIs and how we can create rigorous API tests very quickly. Thirdly, API testing, what's at stake, why is it important, what's the motivation for API testing? And then finally, we'll wrap up with some Q&A. So if anyone has any questions throughout the webinar, feel free to post them in the chat. George is going to be sat there picking them up. And at the end, we can go through them and have a little discussion around them as well. So that's kind of the proposed agenda. So with that being said, now, if you think about the way we're developing software now, it's incredibly quick. Methodologies like Agile and, different development practices that have come in have meant that we can create software very, very quickly. Okay. Now, with that, pace we can develop software at, the complexity of the applications is also growing with it. Instead of having kind of small pieces of software, we're now able to create these large pieces of software, with all these different endpoints and connect them together very quickly. If you think about, even just one API endpoint, you could have 5 or 6 different systems or different pieces of systems that, a message or a data entry point is passing through behind the scenes, okay? So, there's a lot of different possible data inputs And off of those inputs, we're going to be driving all sorts of different decisions in the back end and all sorts of different, systems that data is touching on. So, with this, essentially maze of logic, we need to test it with rigorous sets of data combinations. Okay, so we need to have very high quality data to test all of these different possibilities. And really, the goal here is to actually achieve a high level of coverage that we're testing at. Okay. Now, if you think about a lot of the systems that are out there now, especially ones around open banking and in other kind of mission critical or sensitive data spaces, there's a lot of data in there, which is either personal or financial. And with that, the risk is very, very high. If we have data spillages or we have, some kind of defect flowing through into production, if there's a flawed API, this can mean that, all sorts of impacts for the business. Customers are making very fast decisions now over whether they want to, stick with a company. They can change, almost at the click of a button. So, customers may make a decision to move elsewhere. There's various penalties that are coming in via the ICO and GDPR, and also just damaging a brand, through, not having high quality software. Okay. So, testing APIs is actually very, very important. And, they're usually the piece which actually is kind of the main building block of all of the software that we're producing, right? We may have a UI, we may have a database in the back end, but everything's kind of flowing in and out of that API as kind of the access layer to those assets. So, just kind of thinking a bit more visually here, what we actually did was we took our API and we took a few other APIs as well. And we started to actually do some code scanning on them to look at all the different dependencies in the background that the different data is passing through. Okay. And what you'll see here is that actually there's an awful lot of different, touch points here. So basically, a user may come in at one endpoint with one particular type of data, but it could feed off in all sorts of different situations here. Okay. And, this is essentially what we're trying to think about and try to address here. We may have one endpoint, but where does the data go? How do we test it effectively? And how can we, get a good coverage map, which is testing all these different deviations? Okay. So, one possible solution there is let's go through and test everything exhaustively, but the reality is that's just not possible. We could end up with, more combinations than there are kind of stars in the universe. We can end up with massive, sprawls of possible test cases, possible combinations, even from a very simple system. So we have to go and we have to test much more intelligently than that. And we have to go, higher and start thinking about, different coverage levels. How can I test all of this functionality, with a low number of tests while ensuring that I have a high level of coverage? And that's really what, Test Modeler is all about with model-based testing. So, meeting the speed of API-driven development requires a new approach to testing. Okay, creating API tests one by one in tools is slow and ad hoc. Tests hit just a fraction of logical combinations. Expected results can also be very hard to define. Test data lacks the combinations needed for rigorous API testing, and there's often, not in-house and third-party systems for test execution. So a lot of the time we have to think about virtualization or, given this expected result, what are we going to get out the back end? So with that being said, we're going to jump in and start thinking about, how we can address these problems and how we can actually come in and start, testing complex APIs and trying to offload a lot of that complexity into tools. So our whole mantra revolves around Test Modeler, and that is basically a tool for model-based testing. Now, when I'm talking about a model, I'm really talking about nothing more complex than a flowchart, okay? And we're basically just creating a flowchart of how the application should work, in this case, an API. Given this set of inputs, what is the expected result? or we're building a model or a flowchart of the requirement, how this should work, what we're going to build. And that will then get picked up through development and testing. Now, we have a whole world of accelerators to get started with modeling. Scanners, recorders, you can import service definitions, WSDL files, YAMLs, RAMLs, etc. We can import existing test cases, BDD scenarios, and also existing models. So what we've actually started to find is that a lot of product owners and business analysts are already creating models of how things should work. So we have extensive capabilities to come and take existing models, bring them into Test Modeler so that we can create models from them. Now, once you've got a model, you can create test cases. And the way we do that is we generate the minimum number of test cases to maximize coverage. So whereas before we were talking about all of these possible routes that can occur, we have algorithms that will go into that model, reduce it down, take the minimum set of tests, and push those out. Now, we can push those tests out into your standard project management systems like Jira, TFS, ALM, and other custom formats like PDFs and Excels. We can also do some pretty complex stuff with data. So, most APIs now are, connecting to back-end data sources, okay? And to be able to test those endpoints, we often need to know about what data exists. So to be able to do that, we have extensive capabilities in Test Modeler to come in and start overlaying different test data criteria. Say, go and find me a specific type of data. Or we can come in and we can say, if that data type doesn't exist, go and make it for me synthetically. So this is a concept that we like to call finding data or making data, but really it's no more simple than telling Test Modeler and your test cases, this particular type of test, this is the data that I need, and go off and put it in the right, in the right place at the right time for me within the right data source. Now, the third piece here is test automation. Obviously, in this session, we're going to be talking about API testing. So we're going to be working exclusively with API Fortress and showing our integration there, how we can, very quickly create test definitions inside API Fortress, and how we can then expand all of this data to test many other possible routes through Test Modeler, injecting that into API Fortress. Okay, so this is going to work exclusively across the API layer. Test Modeler also has connectivity into other types of testing, like UI testing and data testing with tools like Appium, Selenium, Cypress. If you're interested in them, recommend you go to the Test Modeler website, have a little look, and there's some videos and tutorials that you can follow to go through them. Now, the fourth piece here is obviously run results. We've executed some tests. Hopefully, most of our tests have passed, but we may have a few failures that have taken place. Now, what we can do with Test Modeler is we can bring back in those run results, overlay them back on top of the model, and you can start to do some root cause analysis. What scenarios have failed? What users are going to be impacted by those failures? Do we care about the failures? And then also you can start to do some root cause analysis. What went wrong? Where did it go wrong? Potentially start to understand why it went wrong using your domain expertise. Now, the main power here is obviously at the beginning we mentioned about, agile, things moving very, very fast, being very hard to keep up with the rate of change that we're facing. Now, with Test Modeler, all we have to do is keep the central model up to date. So the mantra here is we keep the modeling piece always up to date. And then what we will get from that is we will update the test cases automatically. We'll update the test data and the test data environments that are connected automatically. And we will also automatically update our automation scripts and our test automation, which is bound to the model. It's really all about keeping this central model up to date, and then all the other assets around the circle here will be updated for free as part of this exercise. So perfect set of tests, fast maintenance. Everything we're doing here is built around, building up reusable components, reusable libraries. And really, we just want to help organizations move faster, be able to deal with this complexity, and also, you know, providing the assurance that the software they're delivering, they can have confidence in that it's going to work by the time they hit production and into release. So what we're going to be doing in this demo is we're going to be focusing exclusively on some REST API services. Okay. Now, the services here could be SOAP, they could be GraphQL, they could be web services or microservices. So just bear that in mind as we're going through the demo. But what we're going to do here is we're going to take an example of one particular endpoint and one particular request that we're going to be provisioning. Okay. We're going to create a test inside API Fortress. And then what we're going to do is we're going to model the different test data scenarios to drive those tests inside API Fortress. So it's going to be very much data driven, and we're going to be thinking about the different types of data that an endpoint can receive and the different expected results that we might you know, obtain back from those particular data combinations. Now, initially, we're going to do this just by using some hard-coded static data with the different combinations. But what we can also do in the mix here is we can come out and we can start to pull in data from external data sources. So, you know, your SQL servers, your Postgres, your new kind of containerized databases like MongoDB, Solr, et cetera. We can connect all of those in. And what that basically does is it means between, you know, this kind of pipeline here, when we're doing our API testing, we can ensure that we have, you know, good coverage. We're testing a good amount of our API. And we can also ensure that we're going to have the right data to test our API in the right data sources and targets at the right time, just as we execute those tests. So that's basically what we're going to be going through in this particular demo. Let's jump in and have a little look. So what we're going to be doing here is we're going to be testing initially quite a simple endpoint, okay? And this endpoint basically allows us to create new employees. And we're going to be doing a post here along with providing a sample JSON message, okay? So this is the JSON that we're going to be providing. And the result here is that we should get a status of success, and we should get some data coming back here as well, which is the data that has been stored along with an appropriate ID in our data backend, okay? Now, to do this initially, we're going to start off in API Fortress, okay? And this is the API Fortress tool here. You know, it's entirely web-based, can be used in the cloud or on-premise. And what we're going to do here initially is we're going to come in and we're going to create a new test. So I'm going to open up one of my projects that we have here. And what we're going to do is we're going to come in and we'll say, let's create a new test. And this is going to be for our employee endpoint, okay? We'll create that test. Now, the next thing we're going to do here is we're going to come in and we're going to compose the test. And we'll see here we've got a new test that has been created, okay? Now, what we're going to do firstly is we're just going to provide and we're just going to, you know, execute the request down here. So we're going to do a post against this endpoint. And what we're going to do is we're going to use this sample JSON message as the driver to this particular test here. So we'll just come in here and we'll just select to provide some JSON. Just paste that in. Now, if I hit send here and execute this, what we'll see is that this has come back with our data, and this is the JSON that's been provided. Now, one of the accelerators inside API Fortress is that we can come in and we can use this example API request that we've created to actually go in and generate the test definition for us, okay? Now, this is one of the accelerators. As we mentioned at the beginning, we could take some kind of existing service definition, like a YAML or a WSDL file to come in and import that in. But here, we're just going to take an existing one, and we're going to come in, and we're going to say, auto-magically generate a test for me. So we'll generate a data set. We'll generate a HTTP request. We'll generate some assertions. We'll see that we're all set here. Now, if I hit close, what you'll see here is that we have a test that has been created here. Now, Patrick, do you just want to give a bit of an explanation over what's happened here?
Sure. So what API Fortress does is it parses through a response, or you can actually generate a test from a spec file as well. So it parses through and it does its best at guessing what the expectations are. And what it's really aiming to do is go beyond just saying, like, you'll see that some of these things say exist, but then you have something like ID that says integer. So the platform has 65 assertions built into it that allow you to, if you're generating a test in this URL, it'll actually give you a very specific assertion that says this has to be a properly formatted URL. Go ahead, Jim.
Fabulous. Brilliant. Okay, great. So what we have here is that test definition that has come through. Now, if you think about this endpoint, there's a lot of different names, there's a lot of different salaries, and there's a lot of different ages that we could pass to this endpoint, okay? So at that level, we're thinking about the different data that could come through. So in actual fact, there's a lot of different types of messages that we may pass through here. Now, what we can do inside here is we can actually parameterize this JSON message up. I've actually just got one here that I did earlier. Bring that one in. Now, what we've done here is we've essentially parameterized this up with variables. So we've got a name variable, we've got a salary variable, and we have got an age variable as well. So we're parameterizing up this JSON message, okay? Now, bit of best practice here, we could end up with very complex JSON messages, okay? Where, we've got various embedded objects, we've got loops, we've got, a lot of attributes. What we're going to do here is we're just picking out the attributes that we care about, okay? So, even though you may have a JSON message with, 20, 50 different attributes, you may actually only want to take control over a select few of them and expose them into some kind of variable, okay? So we'll take these three. And so now what we can do inside API Fortress is we can also provide input sets, okay? And this is where we can provide different types of data to start to drive our test. Now we're going to provide an initial input set here. I'll call this one initial. And what we're then going to do is we're just going to provide some parameters here. So the first one will provide a name of James. Okay. The second one will provide salary of 20,000. And the third one here will provide an age of 34. And so, okay. So we've basically just provided a little input set here, which is going to data drive this particular endpoint. Now, if I come in here, and let's just save this test, what we can then do is we can come off and run it. So I'm going to come through here and just hit the run button. We'll just run this against this one. And what we'll see here is this is run. We've come back with a status code of 200. If I click see more here, what you'll see is that that has been data driven with that particular input set that we've provided. Okay. Now at this point, you can use API Fortress to go away and do your API testing. And that's going to work excellently, as we've just done here. Now, what we're going to do is we're going to take this one step further, and we're going to start thinking about the data coverage and the different data that can be injected into these three variables. And that's where we're going to enter Test Modeler, and that's where we're going to start thinking about those different combinations and creating a model of that data. So we're inside Test Modeler here. Again, we've got another web-based platform. Can be used in the cloud or on-premise as well. And the first thing we're going to do here is we're going to come in and we're going to create a new project. So this particular project is going to be testing our employee endpoint. So let's create a project for that. And we could come in here and we can select, what kind of automation we want to be using. With UI, we could select Java or Python, or C#, Selenium. Here we're going to select a custom project. We're going to be using API Fortress. And the first thing I'm going to do here is just create a new folder called modules. Okay. And the first thing we need to do is we need to come in and we need to import our test cases from API Fortress. So what I'm going to do is select that modules folder, select our connector here, and I'm going to say, let's go off, let's scan API Fortress, and let's bring in all of the test cases that we have. We'll see here that's complete. If I come into our modules folder here, what you'll see is that we've got a little module, the API Fortress. And what I'm going to do is I just forgot to save that one. So let me just come out here, save this, just come back here and publish it. 1 second. This one. Let me just publish this test so it becomes available. Great. And now let me just come in and just rescan that one. So we've got it. Just put that in here. We're going to scan API Fortress and tell it to bring in our tests and our test definitions into Test Modeler so that we can consume them. We'll see here that that is complete. Come back in, take a look, and what we'll see here is that we have this employee endpoint as something that has been scanned and registered inside Test Modeler. Now, if I come into our models here, what we're going to do is we're going to model out our employee data. So we're going to create a new model. We'll open this one up. And this is where we enter our model editor. Now we can come in here and we can start creating models manually. So if I'm starting from scratch, my endpoint doesn't exist, I can start to model out the different data combinations and the different characteristics of how my endpoint should behave. But here what we're going to do is we're going to use an existing endpoint that we just created in API Fortress. So I'll drag and drop the start block here. We'll come in, we'll select the endpoint here, this employee endpoint. And what we're going to do is we're going to import this. And what we'll see is those 3 parameters have now become available: the name, the salary, and the age. And what we'll also see here is map them to some data rules that already exist in Test Modeler. Now, I'm going to hit save here and bring this in. And then what we're going to do is we're going to take a little recap and have a look at what actually happened. I'll hit save. And what you'll see is that a model has been created for me with the name, the salary, and the ages. And we've also got positive and negative down the bottom here as well. Okay. Now, if we take a look underneath some of these blocks, what you'll see is that they've got some data references. So an invalid name, we've got some numbers. If we look at a valid name, what you'll see is that this has got a little synthetic data generation function associated with it. Now, what I can do here is I can come in and I can access one of our 500 synthetic data generation functions to generate different attributes like phone numbers, names, dates, financials, companies, et cetera, et cetera. Now, that's obviously going to provide us some synthetic data to just push through. But what we can also do is we can go much deeper here, and we could say, go and find me the data I need from some kind of external data source and bring it in to consume in my tests. If we can't find any data, we can also go away and say, go and make that data for me synthetically. So coming back to what we were talking about earlier, built into the test modeler here, we have full capabilities to go very deep with test data through that find, make concept into back-end data sources and targets. So here we'll just stick with that synthetic data generation function. That's fine. What you'll also see is that we've got 3 rules here for different salaries, and we've also got a few different boundary values for different ages. Now, what happened is that we actually have a little library of data rules here. If we see something that looks like a last name, we'll apply these different data rules. If we see something that looks like a username, we'll apply these rules. And what's actually happened here is we've seen something that looks like a salary, so we've applied these. We've seen something that looks like an age, so we've applied these rules. Okay. Now, within specific industries and within specific sectors, what you will find is that there are particular data attributes which are only relevant to that particular sector or even within a particular project. So if we're thinking in the world of finance, we might be thinking about things like IBAN numbers, which we'll take a little bit more of a look at later on. We could be thinking about things like transaction codes, account numbers, et cetera, okay? As we're coming through building the model, if we see something that we already recognize, we'll apply these equivalence classes. If we see something that we do not recognize, we will ask the user hey, what kind of data do you want for this particular data characteristic? And that will then go away and become a reusable data attribute. If we see something that looks like that again, it will get applied in the model. Okay. Now here we've got our model of the different types of data for these three. And we could come in and we could enhance this model, but we're just going to keep it like this. And what we're going to do here is just add an end block in. Okay. And what we've got is a model of the different data endpoints that could be passed through this particular endpoint here and fed into these JSON messages. Now, what we can do next is we can come in and we can say, generate me some test cases or some scenarios. Here, you'll see that we've got 8 scenarios, 8 paths running through our model. And you'll see as I'm flicking through here, the different deviations and the different routes they're taking through the model. Okay. Now, what's actually happened here is when we hit generate, it generated the minimum number of combinations or the minimum number of paths to maximize and cover every single edge in our model. Now, we can be much more expressive over this. We could come in and say, generate me an exhaustive set of tests. If I come in and save that, and we do a generate here, what you're going to see is that we get a much bigger number of tests. So here we've got 30 different paths that have been generated. Now, the idea here is that you have full control over how we're generating these. There may be particular endpoints or particular components of the system that we want to exhaustively test on, and we want to test in a much, richer level of detail. And there may be some other parts of the system that we just want a happy path or a happy journey coming in and out of. Both are possible, and you can be very expressive in here over how you're generating them. Now, once we've got these, we can come out now and we can say, do something with these paths. Let's go off and do a generate back into API Fortress. So we'll select that here, and we'll select to do a generate. And what this is going to do is take each of these paths here, all of these 20 or so, and it's going to publish them back into API Fortress there. We'll see this task is now complete. Let's come back in here. Just do a quick little refresh. Clear our working copy. And let's just take a look and see what's happened here. We'll come in. And what you're going to see here on the left-hand side, if you look at the input sets, we've got a much richer set of data, which we're driving for API Fortress across both positive and negative scenarios. And inside here, we've got the different names that have come through from Test Modeler. We've got different salaries, and we've got different age groups through all of these different input sets. Okay, so this has given us a covered set of data to drive our API endpoint, which we parameterize for API Fortress. And now I can now come off and say, okay, let's go away and run this. So we'll run our tests here. And this is going to go away and run all of those 30-odd scenarios. So we'll just give this 1 minute to run. And that's going through. So we've got a very rich set of data here that we fed in. And we'll see here all of those 30 that have gone through with the different data. And what we should see here is that all of those have passed as well. And we could even go into the very low level detail here and see those actual JSON messages that have been fed into the API. So this is how we can go from essentially an existing API endpoint, feed in a little example, bring that into Test Modeler, and create a covered set of data to go and drive our API tests inside API Fortress. Now, this example is obviously quite simple. So what I want to finish up with here is looking at a bit more of a complex example in the next kind of 5 minutes or so. Now, one of the things that exists in the banking world is IBAN numbers, which some of you may already be familiar with. And these are basically, an internationally agreed system of identifying bank accounts. Okay. Now, IBAN numbers have many, many rules that reside behind them. At the beginning, they have country codes, which are typically 2 letters. They have check digits, and then you have a bank account number that follows. However, depending on the country, you have different bank account numbers, and depending on the whole string here, you have different check digits that can come through. And you'll see here, just by the size of the Wikipedia article, there's a lot of different IBAN numbers that exist in the world. along with a whole different set of formats and rules that can be dictated dependent on the country. Okay. Now, if you do a little Google and you look for IBAN account checkers, you will find a whole world of different API endpoints available for checking IBAN numbers. What we have done is we have just picked one of them out, which is this bankaccountchecker.com. And basically what you can do is you can use this API endpoint, you can provide a IBAN number as part of the post request, or as part of the GET request. And what that will come back with is it will tell you firstly whether it's a valid one, okay? And secondly, it will break it down into different properties, you know, what was the bank account, what was the branch, what was the account number, et cetera, et cetera. So the whole idea here is what we want to be able to do is to come in, take this endpoint and provide and feed a covered set of IBAN numbers into this particular endpoint to test it is working correctly. Okay. Now, what we have done inside API Fortress, which I may have just closed, let me just open that one back up. Bring this open, and then we come up to the project level here. Now, what we have done is exactly the same way as I was just showing you before. We have provided a set of test definitions here, which are going to test that when I provide a valid IBAN, we get a valid response, and when I provide an invalid IBAN, I get the correct invalid response coming back. And if we take a look here, what you'll see is all of that particular data that's been fed in here, and all of the test definition that we have available, okay? And this has been parameterized up so that we're just feeding in different IBAN bank account numbers, which are going to go into our GET request here, where it's parameterized as a variable, okay? Now, what we've done inside Test Modeler is we have produced a model for IBAN numbers, okay? And if we look at this from the beginning, we have two kind of main routes here. The first route is where we're going through and we're going into a database backend, and we're going to find some IBAN numbers that exist inside a seed table, okay? In this case, we're going into an Oracle backend and we're going to look up various IBAN numbers, okay? And at the top here, what we have is we're thinking about the different sets of covered data for different countries. So if we have a country of the UK, we're going to go through and we're going to generate different types of IBAN numbers, you know, different IBAN country codes with different lengths, as opposed to if we go through other different countries here like Belgium, Belarus, Brazil, et cetera, So we've modeled out a few combinations here and the different attributes those IBAN numbers can take. Now, we've not just thought about the positive types of IBAN numbers here, we've also thought about negative and invalid IBANs. So what you'll see here is some of these, if they go through too short, or we have an invalid checksum, or it's too long, we're going to go down a route here where we provide an invalid IBAN number, and that is the result here of this particular flow. We've also got valid IBAN numbers, which are coming through when we provide valid data coming through here, okay? So we've created a pretty rich model. It took about half hour to put together. And basically, the result here is when I hit generate, this goes off and produces a whole world of different scenarios of different IBAN numbers which flow through. Now, for the actual data here, okay, one particular one of interest is this one, where I'm going in and I'm going to provide and look up different IBAN numbers from a back-end data source. So we're doing a mixture here of synthetic, creating them, and also looking up actual ones from a source table, from a seed list. Now, to that extent, what we have inside Test Modeler is a full test data management engine where we can come in and we can start providing connections into back-end data sources and start parameterizing up attributes to go and find specific types of data for me. Here, we're using one which is called Get IBAN. And basically, all this does is it looks in an IBAN table, and it's going to go away and find me one IBAN number from that table for each path that passes through that, okay? And this is connecting to an Oracle instance. We can go much deeper than this. We can start parameterizing and entering custom SQL queries in here, But for now, we're just going to pick one IBAN every time. And the end result is, as I said, we have a full list of different, paths here, which correspond to both invalid IBANs and also valid IBAN numbers, either synthetically generated or coming from external data sources. And again, all we have to do, we can come in here, we can say, go away and do a generate into API Fortress. And just to show you the end result of this, because we're a bit pushed for time, what you'll see is that we now have a covered set of IBAN numbers. Here we're looking at the positive ones. So we've got 2 positive IBAN numbers that have come in. And if I come back here and we take a look at the negative ones, the invalid IBANs, and we open this one up, what you'll see here is that we've got a much richer set of negative, invalid IBAN numbers, which are going to feed in to this particular test case. So just to kind of summarize what we've done here, we can use API Fortress to very quickly connect to API endpoints, existing ones, or specification files. We can create tests in API Fortress very quickly. We can expose them to Test Modeler, and then we can drive very rich sets of covered data into those test cases for execution. So that was the demo. So just to summarize, it provides a simple way to test complex APIs, provide a specification, model the complexity in Test Modeler, and then expose that data back out. You can move faster by quickly and synthetically generating test data to go into your test cases, have the right data in the right place to support those tests, and you can also run the automation suite on demand in the cloud for API Fortress. And this obviously increases quality and confidence. We're thinking about, the different types of data that can pass through that endpoint. And really, we just want to be testing more rigorously here so that we can find bugs much earlier in the release cycle, because we're testing, many more combinations against our API endpoints. So with that said, Patrick, I'm going to hand over to you to talk a bit more about API testing.
Sure, thank you. If we could switch over to the first slide, perfect. So the big thing, and the reason why we work so well with Curiosity, and I'm going to get through this in about 5 minutes, then we can go to the question and answer period, is that the data really is key. Like a lot of we see a lot of false positives, meaning people run a test and it seems to work, but then when it actually gets to production, it's not successful. And a lot of that is due to just the lack of data they are using when testing. So very specifically, like you need to make sure you're going beyond just a 40 item CSV file, which it might seem obvious to some people, but that's actually the vast majority of the test data we see when we're speaking with customers. So it's this really important thing of like, make the data dynamic, large, really test things out. And occasionally don't be afraid to use production data as like what the basis might be. If you want to go to the next one, please. James. Thank you. And so the next part is integration testing. And so as part of our sort of best practices, one thing we always tell people, and what we showed you today were fairly simple like endpoint exercise tests. They just sort of hit an endpoint and test it against it. But you should also be creating integration tests. There might be called end-to-end tests in your organization, meaning reproducing an entire user flow in one test. So with API Fortress and other tools that are good at API testing, you can do tests that they'll do search, add to cart, and checkout all in one flow. That's really important to do because the whole purpose of APIs is how they interact with each other. And without testing that interaction, you'll never be completely confident that it actually is working as expected. And also another important thing to note is you should be testing for good and bad test case scenarios, which we saw an example of that today, but that can also be done in a single test. So you can actually say if it's a 200, we expect this. If it's a 401 with error messaging, this is what we expect the error message to be. That sort of level of granularity is really important when creating your tests, because there's a big difference between something responding and having every single part of it accurate. The one analogy I always make to people that are asking me about API testing is that think of an API as a book. And so every single API call is an entire book. And what API Fortress and API testing platforms look to do is to proofread it. But the difference is that something as small as a typo in that entire book can ruin the entire thing. I've worked at companies where we had a comma out of place or semicolon out of place, and it caused a customer not to make revenue for 24 hours. That was actually one of the genesis of where API Fortress came from, was that experience that we had to deal with one of our customers. James, if you can go to the next. And so this is something that's not spoken to enough, but it's actually significant. It's the monitoring of your API. So a lot of people are fairly comfortable saying, oh, we monitor APIs because they might be using tools such as a Datadog or New Relic. But there's actually a very big difference. So what we're talking about here when we say monitoring is the actual monitoring the functionality, meaning those end-to-end tests and those functional tests you are using as part of like your CI pipeline, those can be scheduled to run as a monitor. So in API Fortress, you can use your end-to-end test, schedule it to run every 5 minutes against various environments, pre-prod staging, gold staging. And you could use it to make sure that your APIs are actually delivering as expected. Because again, APIs are the backbone of your mobile apps and your systems today. And so only knowing that it's up isn't enough. Only knowing that it ran pretty quickly isn't enough. You need to make sure that, again, it's like a book. Every single spelling has to be correct. If it's supposed to be a URL, make sure it's a properly formatted URL. These are the sorts of problems that occur today because when people set up API tests and platforms like a Datadog, they aren't going above and beyond. They're just doing the bare minimum. With API Fortress and the generate tests and curiosity, you're actually able to create these really robust tests quickly. Next slide, please. And so the part that's really interesting and something that's a bit unique to API Fortress is the performance testing being part of it as well. So performance testing means multiple things. At its root, it can mean how quickly a call is made. So the latency and fetch of like a single API call. That's important to be monitored when that's not working as expected, and that's something you can actually assert right within an API Fortress test. So you can be notified if it's longer than 500 milliseconds. Something to keep in mind is to make sure that an API's payload is not too large. This is a problem that's happened often. Some APIs don't have pagination set up properly and the payload is too large, and it actually leads to mobile apps crashing and not working on some mobile devices. So it's certainly something to keep track of, the total fetch size. But also what this means is load testing, stress testing. So in API Fortress, you can actually use your existing functional tests again and use it as a load test. And the importance to that is it's validating not just the load and the performance of the API under stress, but it's also still doing that functional work. And two great examples of the purpose of this is, first, it helps you quickly diagnose and find memory leaks, which happen all the time. So it helps you find that right away, just by pushing a few buttons. And secondly, and this is a very difficult thing to find if you're not specifically looking for it, and just last week, we actually had a customer that this bug revealed itself, is under load, not every object may respond as expected. So very specifically, like you can have an entire payload, but one object may be fed by more of a legacy database that can't keep up when you're doing 5,000 hits per second. So it's important to be validating not just that the API doesn't collapse under load, but it's actually responding correctly. And that seems sort of counterintuitive that the computer couldn't keep up, but that happens all the time, especially if you're working at a large enterprise, because what we're dealing with are legacy and monolithic microsystem services. And then what we've tried to do these days, and a lot of these people are, they're doing their digital transformations and they're converting them into APIs, but at the root might still be these legacy servers that are struggling to keep up. And if you go to my last slide, James. And so finally, like the big thing that comes up often with our European and Canadian, Australian and American bank customers are talking to us about this now is PSD2 and what it really all means. So there's positives to it. The positive is that it's helping customers have their own banking history revealed. The negative to it is that just them saying the word PSD2 didn't necessarily create this very strict and well-organized standard. And so it's important to keep two things in mind. The first thing is that not everyone's implementation is going to be identical. Different countries are actually doing different implementations. So it's important to have a system when you are building these APIs and you make a decision about testing them, to have a system that's actually flexible relative to creating these tests. Because you could download the PSD2 standard and generate a test from it, and that'll give you a decent amount of coverage, but it'll never be perfect because no two companies can be completely aligned, especially with the not strict enough, we believe, but there's conversation about that, but not strict enough PSD2 standard. And just the fact that PSD2 is not a global standard. America, for example, doesn't have open banking. That's why a company like Plaid exists today. And then secondly and finally, it's with open banking, APIs are now releasing your personal information out there. And it's important to monitor these things. And specifically the monitor we've been suggesting to all of our customers is when you make a request for, let's say, my information, you're looking for a transaction history of Patrick Poulin. If you get anything but Patrick Poulin's transaction history, that's a very bad thing. And it sounds like it can never happen, but we've seen it happen. So that proper analysis, and that's what we mean by end-to-end tests and recreating user flows, the call and the response, comparing the items, making sure they're lined up. That's a significant need, and it's really useful to do that with a lot of different test data, such as like what Curiosity can provide for you. So that's what I have in terms of best practices for API testing. James?
Absolutely excellent. Thank you so much for that, Patrick. So, I think, what's next? If you're interested, you want to give this a go yourself, you can visit testmodeler.io to start a free trial of TestModeler. You can also visit apifortress.com to get started with your API testing. I would say, it doesn't really matter which one you start from. You're going to get some value pretty quick. We're also just putting together the TestModeler API Fortress tutorial at the moment, which you'll find at testmodeler.io/tutorials early next week. And there's also, we'll follow up with the slides and the webinar recording after the session. That should be live within a few hours. So with that being said, George, I'm going to hand back over to you, who's going to pick up any questions that have come through. If you've still got any questions on the top of your head, now's the time to post them in, and George will pick them up.
Thank you, James and Patrick. Really interesting demo and presentations there. Yeah, as James said, if anyone has any questions for us, please don't hesitate to stick them in the Q&A or chat boxes below. Okay, so to start with, we've got, is there an industry standard or reference you would recommend to base the design of your API model against?
Sorry, mute. Is there an industry standard or reference you would recommend to base the design of your API model against? Yeah, that's a really good question. So in terms of, the parameters, what's coming in, what's coming out, I mean, that's going to be dictated by the API. In terms of actually how we model, there's some fantastic sessions out there by people like Paul Gerard, who have introduced various kind of topics and different, PowerPoints and material based on how to model. The best practices from our point of view is it's always best to keep things as simple as possible. If you end up with an absolutely massive model, then something has probably gone wrong somewhere along the lines. So it's kind of best to try and keep things as componentized as possible. What you'll find inside TestModeler, we didn't go through them in this session, but we have the concept of sub-processes. So you can come in, once you model something once, it becomes a reusable sub-process. But also, second to that, it allows you to componentize things and keep them into small kind of consumable chunks. So I would say the best kind of industry standard is actually just to keep things small. But in terms of, is there something to base the design of your API model against, in terms of model-based testing, not particularly. From the API side, Patrick, any kind of standards that come to mind?
No, nothing specifically. The one thing in terms of standardization that's really come along lately is spec files. So you can design your APIs before you even build them, and that means using something like the Open API Initiative or Swagger or MuleSoft uses RAML. Like those spec files are sort of what we're talking about, their standards, because they build those as the design in the design phase, and then when they execute and build these APIs, they're supposed to be aligned with that spec file. So if in our platform, for example, you generate a test from the spec file and run it against the API, it should work if the spec file is properly written and if the API was built as per the spec file.
Okay, brilliant. Okay, I suppose this one's directed towards you, Patrick. Can API Fortress handle authorization schemes, including three-leg OAuth?
Oh yeah, that's actually that's a good one. So yes, and that's why the platform is able to do end-to-end testing, because you can do multi-step testing, and authorization schemes are multi-step. So make a post to get a token and then use that token in the subsequent call. That's the sort of stuff you can do in API Fortress very easily. It's a requirement if you're dealing with APIs. The three-leg OAuth is actually something we just finally were able to succeed with. We actually have on our GitHub something called 3LOA. So it's three-leg OAuth. It's on our GitHub, and it's an open source, free helper application that we built to facilitate the process of actually getting through these three-leg OAuth. So it helps you with logging in using, let's say, third-party application. And I don't want to mention them, but the reality is, like, it's actually against the terms of service often to automate that process. But a lot of us built off of that process, so we have no choice. Like, we have to test it. So we built that out there for anyone that's interested in handling three-leg OAuth.
And this is so useful, by the way. I mean, when it comes to doing, automation, authentication is always the hardest bit. So having these kind of accelerators where you can just click and go, that just saves so much time and makes it so much easier to get started actually getting value. It's amazing.
Yeah, we actually quite literally built it because we had a customer saying that they were doing manual testing. So they would try to do it every like 20 minutes. They would manually log in to make sure that their API was working, but first it required that three-leg authorization.
Mm-hmm.
They couldn't find a way to automate it. So it's what we built it for, and it's ended up becoming very popular in our repo.
Amazing.
Great. How is it possible to model APIs accurately and quickly enough to test them? What if some are third-party APIs?
I'm sorry.
Sorry, mute again. Sorry, can you just repeat that one, George?
Yeah, sure. How is it possible to model APIs accurately and quickly enough to test them? What if some APIs are third-party?
Yeah, so I mean, in terms of being able to model them quick enough, I think, the real core here are kind of the accelerators that API Fortress bring to the party. Being able to take a specification file, being able to quickly create the test definitions from them, also being able to, consume an existing, web call, being able to go through and then import that into Test Modeler and provide that as kind of the foundations for modeling, makes it very, very quick. Because at that point of view, you're just thinking about, you're kind of minimizing all the complexities. It's like Patrick said, an API endpoint is like a book. There's a million different things that can happen behind that endpoint. But at this point, what we're saying is API Fortress has exposed to us the parameters that we care about, and we want to take control over and make sure that we're hitting, a high level of coverage for. So we're taking that definition and we're just exploding it out in Test Modeler and saying, these are the negative data that can go in there. This is the positive data. And then let's drive that through those particular parameters. And let's turn the pages in that book as we're going through and make sure we're covering every single one. So, in terms of being able to move quickly with API testing, the combination of the two products is really the power here. If you can't model, you don't have good data, but also if you don't have API Fortress, you can't create your tests very quickly and expose them. So the combination of the two is what actually provides the power here to be able to test the API effectively and quickly.
Yeah, and one final item is just we have some customers that use us exclusively just to test third-party APIs. So that's an important thing, not not to ignore at all. Like for example, like one of our customers has, they use us to do functional monitoring of payment processing APIs. So when you think about it, while they're not their APIs, the ability to execute payments and get paid depends on those APIs. So that's why they've taken the uptime monitoring of them functionally very seriously.
Okay, does API Fortress test GraphQL?
Yep, you can actually just look that up in our docs, but GraphQL is supported as well. It's become a significant talking point as of late. A lot of people are really looking at evolving to it.
Okay, I think we've got time for one more before we wrap up. I need to test against multiple versions of a response. For instance, when one part of our system is using previous version of our APIs to send requests, how is this possible in this approach?
Yeah, so inside API Fortress, what you can do is, if you're thinking about chain testing, you may not just be thinking about one API call in isolation. You may be thinking about, multiple API calls all chained together, and you may need to pass parameters between them, and dependent on, something that came back earlier in the chain, I'm going to have and set an expected result later in the chain, right? So to that extent, if you think about it, all of these are just models. I'm going to model one endpoint and then going to chain it with a second endpoint and then going to chain it with a third endpoint. Okay. So all of this can be provided, inside API Fortress by connecting them together, and also just inside Test Modeler by connecting these components together, we can drive the data into those particular chains as well. So, when you start getting into the weeds and you need to start thinking about chain testing, that's 100% something that could be supported and exposed via both products.
All right, thanks very much. Great answers, Patrick and James. That's all we've got time for. So if you have any further questions, please don't hesitate to get in touch with anyone at API Fortress or Curiosity Software Island. Head to the website for free trials and booking a demo. And yeah, thank you very much, Patrick and James.
Thanks, George.
Yeah, thank you so much, everyone. I've just put our emails on the screen there. So thank you, everyone, and have a great day.
Thank you much. Bye-bye.
Thanks.
Thanks, George. See you. Bye-bye.
Bye.
Bye.